let's go through our data virtualization designer within JBoss Developer Studio. That's part of the JBoss Developer Integration Stack. I've created the financials TID project. TID is a community project that data virtualization is based on. So this is the TID designer, which is a data virtualization designer. I've started the project and I created my folder structure with data sources, the enterprise data layer, schemas, virtual base layer, web services, so I could separate the content into logical folders. And so we're going to start with data sources. And so we import the metadata for all the various data sources, and we go File and Import. And we can start importing different data sources. So I did JDBC database import, the flat file import, web service import, and built my data sources. And so the metadata that's imported, for instance, relational databases, Designer does this by connecting to the databases via JDBC and imports metadata such as the names of the tables in the database, the name of the columns, the data type of the column, so forth. And then for web services, does it by reading in a WSDL for the web service with importing the schema for the request and response. And we build several layers of view models on top of this data source model. And that's typical within data virtualization, a data virtualization project with multiple layers of view models on top of the data source models, because with this transformational logic in each view can be fairly simple. And then complex data transformations are achieved by use of several layers of views. And in traditional relational databases, such a design, that would be fairly heavy performance penalty at runtime to deal with all the different layers of views. And that's why in a traditional database, you'd see a use case like this defined in a single view, very lengthy and complex SQL statements. But one of the awesome things of data virtualization is compresses all these layers at runtime to a single layer. So there's really not such a penalty using layered views. So when we look at these data sources, I have the web services, CSV, the JDBC to Postgres. We can, for each of these, you'll see our tables, I can go and run preview data, and I can look at the customers directly from the data source. So I can do this preview. Then if we move on to, excuse me, and you'll notice we have our server listed, and within this server for EAP, which is what data virtualization runs on, we have our data sources, translators, VDBs, and I've already deployed that VDB with the data sources to the server. You'll see the financials VDB there. But I can go to that server. I can click on TID instance, click on test my administration connection, test my JDBC connection, and you'll see I'm connecting to data virtualization. So let's go on to our virtual base layer. And this is the first layer that we've defined. And this model layer is a series of views that's really a one-to-one correspondence to each of the source tables. And the reason we do this is just to add an abstraction layer to handle any future changes. I like to call it future-proof. So these future changes to the data source schemas, this abstraction layer helps abstract that from the higher level model layers. And so again, if we come into the VBL, we can choose one of these tables and we can preview that data. It'll just take a second. And so after this virtual base layer that we've built, you'll see the data just came back here. From the virtual base layer that we just built, we're going to build another layer, the enterprise data layer. And with the enterprise data layer, what we can do is use a data dictionary to help with the data types. And one of the ways that this helps us in this technique is take, for instance, the EU customers and the US customers. Say the US version has a middle initial only in the customer table, and the EU version has middle name. And so with these semantic differences, a little bit easier to use the data dictionary that defines these types. And so we've used that within the enterprise data layer. And this way we can ensure we get all data for a particular field into the same data type, and gives us a guide to resolve any differences in field names between the two. And again, here I can go and I can do preview data here as well. You'll see all the data comes back. And so the next layer that we can add is a federated data layer. And this is useful at aggregating or federating data across the different enterprise data layer. So say, for instance, customer, we want to combine all the customers from EU and US into all customers, which is one of the objectives we have with the demo. Is we wanted to be able to grab all the customers from both regions and give that all customer view. And so here I've defined the all customers, and I can also go into preview data here. And it should come back with all the customers, even US. So the country for US is in the US customers database. And so now we define the data source. We define in the virtual base layer, the enterprise data layer, the federated data layer, and we can also have a virtual query layer, which is web services. So we'll go over to web services. We can actually go into all customers. We can go into get customer, go into preview data, and so we can get the all customers with this get customer. Let's put in one CST 33. Oops, 33. And we're just going to get this one customer just to show the web service, and so you'll see that the web service returns that customer for us. And so the last thing within the designer that I want to show, the financials, VDB, we can execute that virtual database, and this is going to give us the database development perspective. But if we go under catalogs, financials, schemas, go under all customers, look at the tables, you'll see it has customers here. So what we can do is we can put in the all underscore customers dot customer customer. Now what we can do is execute current text. And then there you see it's returned all customers, the USA country customers plus the others.